Radians, degrees, and arc length. An angle is determined by rotating a ray about its endpoint. The starting position of the ray is the initial side, and the position after the rotation is called the terminal side. Positive angles have a counterclockwise rotation, while negative angles have a clockwise rotation. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. Angles can be measured in radians or in degrees. We're generally used to degrees, but the one rotation of a circle is 2 pi radians, or we would say it is 360 degrees. Both are correct. We will generally be working with radians. Now, to convert between degrees to radians and vice versa, we have a couple formulas to remember. If we have n degrees and we want to change it to radians, we're going to multiply by pi radians over 180 degrees. And that's going to give us m radians. We can also go from radians to degrees. So if we have m radians, then we can multiply by 180 degrees over pi radians, and we're going to get n degrees. So we should be able to go from either direction. Alright, so now we're going to convert from degrees to radians or radians to degrees. In the first one, we have 135 degrees, so I'm going to change it to radians by multiplying by pi over 180. And then I simplify. I have 135 pi over 180, and the degrees are going to cancel out. So I simplify that fraction, and I get 3 pi over 4, and that's radians. And the next one, I have 7 pi, so it's in radians, and I'm going to change it to degrees by multiplying by 180 degrees over pi radians. The pi's cancel out, leaving me with 7 times 180 degrees. So I'm going to multiply that, and I get a final answer of 1260 degrees. So the next one, we have negative 270 pi. So if you were to multiply by pi over 180, then you would get a negative 3 pi over 2. And the last one, 4 pi over 3. You can write that pi in the top. It might make it a little bit easier to understand what's going on. And then I'm going to multiply by 180 over pi. Pi's cancel. And then I multiply straight across and then divide by 3. And you should get 240 degrees. Now we're going to apply some word problems. If a circle has a radius of r and a central angle of theta, then we can find the arc length by s equals r times theta. You need to note that theta needs to be in radians for this to work. Now, the linear speed of a particle measures how fast the particle is moving, and the angular speed is going to measure how fast the angle is changing. So the formula for linear speed is going to be arc length over time. Or we simplify that to s over t. And the angular speed is going to be the central angle over time. So that would be theta over time. So let's do some examples of this. A circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle of 240 degrees. The first thing we have to do is we need to convert our theta, right now it's in degrees, and theta needs to be in radians. Okay, so we need to convert 240 degrees to radians. So I'm going to multiply by pi over 180 degrees. Cancel out the degrees, simplify that. And theta is going to be equal to 4 pi over 3. So now that's going to be my angle measure. So now I put that in. We're looking for arc length, so S equals R times theta, which is going to equal 4 times 4 pi over 3. 4 times 4 is 16 pi over 3. So my arc length is 16 pi over 3 radians. In this next example, we want to find linear and angular speed. The second hand of a clock is 10.2 centimeters long, and that's all we know. So we need to break it down one step at a time. So let's look at what is one revolution around a clock. Well, it's 360 degrees or 2 pi radians. So one revolution is going to be 2 pi radians. And how long is it going to take to go around 2 pi radians? Well, we know that time is 1 minute or 60 seconds. So that's going to be important information for us. So now we're going to look at what is my arc length. What is the area around, the length around? So S, the arc length, is going to be 2 pi, because that is my angle measure. R. My R is how long the second hand is, 10.2. So S equals 2 pi times 10.2. Multiply that out, S equals 20.4 pi. Okay, so once I have that, then I can find my linear and angular speed. So linear speed is going to be my arc length over my time. So that's going to be 20.4 pi divided by my time, which is 60 seconds, which is going to give me approximately 1.07 centimeters per second. Now I want to find angular speed. And that's going to equal my angle measure divided by my time. So that's going to be 2 pi over my time, which is 60 seconds. So if I divide that out, I get pi over 30, which we could also write as 0.105 approximately, and that is radians per second. For this next example, we want to find the area. A section of the face-off circle in a hockey rink is a circular sector with a radius of 2.25 meters and a central angle of 65.8 degrees. What is the area of this section of the face-off circle? Now, the first thing we're going to want to note is that the area of a section of a circle is going to be equal to the arc length divided by 2 pi r, which is the circumference of the circle, times pi r squared. So that's going to be the formula we're going to be using here. So the first thing I want to do is I want to find my arc length. So S equals theta times r. So I need to first find my theta before I can go on and do this. So theta is going to equal 65.8 degrees times pi over 180 degrees, which you can approximate that to a decimal if you want, or if you want it to be exact, that's going to be 329 pi over 900. If you want to write it as a decimal, that's fine in this case. So now let's find our arc length. S equals 329 pi over 900 times my radius, which is 2.25. Now, if you type that into the calculator, if you stick with the fraction route, then it would be 329 over 400 times pi. So that is my arc length. So now I'm going to take that and put it in for my arc length and then put my radius in and solve. So my area is going to equal my 329 pi over 400 divided by 2 pi times r, which is 2.25, times pi 2.25 squared. So it's just a lot of calculator work at this point. So if you were to type that into the calculator, A equals 2,961 over 3,200 times pi, or you could approximate that to 2.907, and that is meters squared. So that's the area of this section of face-off circle. So those are your notes over radians, degrees, and arc length, and how to apply some of this information. Go through the practice problems, and then you can prepare for your quiz over the material.